Greetings, Earth and Space Explorers. Welcome to Doc Waller's Earth and Space Report for Friday, July 26, 2024. I'm your host, Bill Waller, an astronomer, science educator, and communicator, coming to you on what was a balmy summer's evening in my hometown of Rockport, Massachusetts. These Earth and Space reports are intended to engage and inform people like you who are curious about Earth as a planet, who care about our life-sustaining biosphere, and who wonder about the greater cosmos and all that it has fostered throughout space and time. Video recordings of these reports are archived on the Earth and Space Reports YouTube channel. I am grateful for the continuing interest and support shown by Rockport educators and students, Cape Ann cultural colleagues, cohorts of the Gloucester Area Astronomy Club, sundry Earth and space scientists, educators, and communicators around the world, far-flung friends, family, and other curious folk. Thank you for your active participation, comments, and general encouragements. For this episode, I'm excited to host Dr. Travis Rector from the University of Alaska, who will describe for us the relevance of astronomy to the issue of climate change. Dr. Rector is a professor of physics and astronomy at the University of Alaska in Anchorage. He is also a co-founder of Astronomers for Planet Earth, A4E, an organization of over 2,000 professional and amateur astronomers who are working to educate and advocate regarding the issue of climate change. He has just finished putting together a book called Climate Change for Astronomers and is leading a task force for the American Astronomical Society on this issue. I first learned of Dr. Rector through the amazing astronomical images that he obtained with some of the premier ground-based telescopes at our national observatories in Arizona and Hawaii. This evening, Travis discusses what can astronomy tell us about climate change, a highly relevant subject nowadays. At the very beginning of our gathering, I neglected to press the record button. I have since re-recorded this introduction and appended the great majority of Travis's presentation, which follows.
In teaching introductory astronomy classes, we always got to the point of talking about the planets in the solar system. And when we would talk about the planet Venus, of course, talk about how it is a raging furnace at about 880 degrees Fahrenheit and is much hotter than the planet Mercury, even though Mercury is closer to the sun. So why is that? Well, the simple answer is because Venus has a thick atmosphere made almost entirely of carbon dioxide, which you probably know from hearing about climate change. Carbon dioxide is a greenhouse gas which traps in heat. So this thick atmosphere of Venus makes it over 800 degrees Fahrenheit day and night. So in teaching this to my students, a lot of my students started to have questions about climate change. They wanted to know, is this what's going to happen to the Earth if we don't deal with climate change? And while the answer to that is no, we're not going to turn into Venus anytime soon, we still do need to be very concerned about climate change. And so I found that in astronomy, I was regularly being asked by my students questions about climate change. And I want to emphasize that astronomy is more than us just trying to be climate scientists. We have our own unique perspective on the problem. And I think that is best illustrated by looking at some of the quotes that have come from astronauts that have gone out into space, and in particular, the Apollo astronauts who went out to the moon and saw the Earth from a distance. And so here are some of the quotes for them. Neil Armstrong, of course, the first person to walk on the moon, said that when he saw the Earth from afar, it looked like a tiny pea, and it gave him the sensation of feeling very, very small. When Alan Shepard went out to the moon, he cried. He was literally brought to tears when he saw the Earth from this distance. And this is probably my favorite quote, and this is from Jim Irwin of Apollo 15. And he said that as he viewed the Earth as they were flying away from it, as it got smaller and smaller, he felt this profound sense of just how fragile and delicate the Earth was. And all of the astronauts, including Jim, felt a profound sense of change in their perspective about the universe from seeing the Earth from afar. And this is often called the overview effect. It's also sometimes called the astronomer's perspective, because as astronomers, we understand innately that the Earth is a finite resource, and really truly the only place that we can live. And when we look at the other terrestrial planets in our solar system, when we look at Venus and Mars, these planets have cautionary tales for us. We know that Venus, of course, is too hot to have life. And when we look at Mars, we actually are looking at a planet that once had Earth-like conditions on it. It was a place that once had liquid water on its surface and could conceivably have had life. And so Venus, the histories of Venus, Earth, and Mars are just, prove to us that planets don't necessarily turn out to be habitable, and they don't necessarily stay so. And one thing I'll mention is that often when it comes to talking about climate change, sometimes people will say things like, well, can't we just go to Mars if things get really bad here? Or maybe even some of these exoplanets that have been discovered, over 5,000 now exist. Well, the reality is that these planets, including Mars, are just much too far away for us to get to. And if we were to develop the technology to be able to travel to these planets and make them habitable for us, we can also fix the problems here on Earth. And so I really see it as like if you had a bagel catch fire in your toaster, you wouldn't just say, well, let's just let the house burn to the ground and go find another house to live in. You'd fix the problem, right? So that's kind of where we are with climate change. So in teaching climate change, and this is research that has been done by many people who've looked into what people think about climate change, there's common misconceptions that come up, and many of them are astronomical in nature. So perhaps the most common thing you hear people say nowadays is that climate change is natural. And so either we shouldn't worry about it or we shouldn't think that we could be causing the problem. Sometimes climate change is blamed on the sun or volcanoes or some other natural phenomena. And one of the most common misconceptions is that scientists are unsure about it. So I'd like to talk a little bit more about these in particular. So how do we know the history of the Earth's climate? Well, if we want to look back more than just the few hundred or thousand years of human history, then we need to use geological markers. And one of the ways this is done is through what are called ice core samples in Antarctica and in Greenland and other places. Every year when it snows, that snow falls on top of the Earth. And then every year more and more snow packs up and it turns into ice. And so the further down you go, the further back that ice originated. And so what scientists do is they dig down into the ice and pull out what are called these ice core samples. And each layer in the ice core contains these little bubbles of gas. And what you can do is analyze the gas inside those bubbles, and that'll tell you two things. First, it'll tell you what gases are in there. So it'll tell you how much carbon dioxide was in the Earth's atmosphere at the time that ice froze. And you can also use what are called proxy measures to determine what the temperature was at that time as well. And so using this technique, scientists have been able to put together a detailed history of about the past million years or so using these ice core samples. And I'm going to try to minimize how many plots that I show because plots are inherently boring, but this is a really interesting plot. It tells us a lot of really cool stuff. So you'll see two squiggly lines on here. First, you'll see on top a blue line that goes up and down, and that is how much carbon dioxide was in the atmosphere at that time. And in these plots, the right side of the plot is the present. And as you go left, you're going further and further back in time. And then the red line shows what the temperature was in Antarctica at that time. And if you look at these two lines, you'll see that there's a very close connection between them. That as there's more carbon dioxide in the atmosphere, the temperature was higher. And so there's a very strong connection between how much carbon dioxide is in the atmosphere and what the temperature is. Now, looking at this plot, you'll see that these natural variations here are the amount of carbon dioxide in the atmosphere varies between about 200 to 300 parts per million. Now, you'll also notice here that there's a cycle, that you'll have periods where it'll get warmer, and then it'll cool off and then get warmer again. And this happens roughly every 100,000 years or so. So what's causing this? Well, It actually has to do with how the Earth orbits the sun. And these are known as Milankovitch cycles. And there's actually three things that are important here. The first is the tilt of the Earth's axis. You probably remember from your introductory astronomy class that the Earth's axis is tilted relative to its orbit around the sun. And this tilt of the axis is the reason for the seasons, that during the summertime, the Earth's axis is tilted towards the sun, meaning that hemisphere gets more sunlight and it gets more intense sunlight because the sun is higher in the sky. Now, this angle changes a little bit. It varies between about 22 and 24 and a half degrees. And the more the axis is tilted, the more extreme the seasons. The hotter it is in the summer and the cooler it is in the winter. Another factor is how the Earth orbits around the sun, in particular, the shape of its orbit. And this is known as eccentricity. If the Earth was orbiting around the sun in a perfect circle, then it would be the same distance from the sun all the time. But the Earth's orbit is not perfectly circular. It's a little bit egg-shaped. So there's times when it's closer and times when it's further away. And right now, it's at its closest around the month of January. And changes in this eccentricity occur because of the other planets in the solar system. Jupiter and Saturn in particular tug on the Earth and cause the shape of its orbit to become slightly more elongated in this 100,000 year cycle. And then finally, the axial precession, the tilt of the Earth's axis. The Earth is spinning, and just like a spinning top, it wobbles. And so this wobbling takes about 26,000 years for it to complete a cycle. And what this does is it changes at what point in the Earth's orbit do you have summertime in the northern hemisphere. Now, these three things combined together can change how extreme the seasons are, and that will lead to these cycles of times where it is a little bit warmer and a little bit cooler. So looking back at this plot here, you'll see that there's times when the Earth is a little bit warmer. These are known as the interglacial periods. And when it is cooler, these are known, of course, as the ice ages. And I just want to point out here that looking on the scale, just for perspective, Homo sapiens, or modern humans, appeared somewhere between 200 and 400,000 years. But what's most important is the last 10,000 years or so. And this is a geologic period known as the Holocene. And this is really the period during which the Earth has been as it is now. And this is a really important period in human history because it was during the Holocene that led to the formation of agriculture and civilization and basically life as it is now. So what I want you to notice from this plot is that the Earth's climate has varied naturally over this time period, and the amount of carbon dioxide in the Earth's atmosphere has varied naturally between roughly about 200 to 300 parts per million. Well, what we've been doing for the last 100, 150 years or so is burning fossil fuels and adding additional carbon to the Earth's atmosphere. And as a result, we have spiked the amount of carbon dioxide in the atmosphere to now over 400 parts per million. So the key thing I'd like for you all to take away from this is that the Earth's climate does vary naturally, but what's happening now is very unnatural. We have spiked the carbon dioxide levels much higher than what happens naturally. And this is the human-caused climate change that we're so concerned about. Okay, so other factors that sometimes are brought up when it comes to climate change is the sun. The sun does change its brightness, and since the sun is our primary source of energy here on Earth, it's a natural question to ask, could the sun's brightness be playing a factor in the Earth's climate as well? And it does on very long time scales, but does not play a role in the last few hundred years. And in fact, this plot right here shows how the sun's brightness has changed, shown as the yellow line on the bottom, as compared to the temperature of the Earth. And in particular, I want you to see that from about 1950 onward, while the Earth has gotten hotter, showing that red line going up, the sun is actually dimmed ever so slightly in brightness. So we know for certain that the sun is not the reason why the Earth has gotten warmer during this time. And in fact, climate scientists have looked at every possible explanation as to what might be causing the Earth's temperature to rise as it is right now. And the only way that you can explain it is through the addition of carbon dioxide by as released from the use of fossil fuels. It's not the sun, it's not the Milankovitch cycles, it's not volcanoes, it's not El Nino. We know for certain that it is these greenhouse gases. And I want to emphasize this part because we know that these greenhouse gases make things warmer. And it would actually be very unusual if the Earth didn't get warmer by the addition of these gases. This is exactly what we expect. So research has been done on how certain are scientists that climate change is real and human caused. And there's been many studies that have been done over the year that show that the overwhelming majority of scientists, climate scientists, agree that climate change is real and is human caused. And the most recent study I saw a few years ago, they looked at over 3,000 climate research papers published in the last 10 years or so, and over 99% of these papers agreed that climate change was real and human caused. Now, this is interesting for a couple of reasons. One is that even though scientists are overwhelmingly certain that it is happening, if you ask the public, they have a very different picture of it. In fact, roughly half of Americans think that scientists are still not sure as to whether or not climate change is real or happening. So the natural question to ask is, well, why is this? Why is it if scientists are so certain that people don't think they are? Well, there's a variety of factors, and you can probably guess what some of them are. The reason, or there are several reasons why this is. Part of it is simply that climate change involves a lot of money. The fossil fuel industry is a very wealthy industry. And this plot right here of this table shows which companies are the largest in the world based upon how much money they make. And of course, Walmart is on top. God bless them. You can't get anything these days without going to Walmart, right? But if you look at everything else on the list here, you'll see that the majority of these companies are either related to the fossil fuel industry or they use products that do, such as Volkswagen and Toyota. So the good news is that dealing with climate change is as straightforward as changing how we use energy, but there's a lot of money on the table. And unfortunately, some of these companies have been caught spreading misinformation about the scientific consensus. In fact, a recent lawsuit against Exxon, they were required to reveal internal documents, and these documents showed that they took a position of emphasizing the uncertainty in the scientific conclusions about the greenhouse effect. And this was all done at a time when Exxon's own scientists had actually made very accurate calculations as to how the climate would be changed based upon the use of fossil fuels. This is also something that unfortunately many companies have also been, these fossil fuel companies have been giving money to organizations that also spread doubt or skepticism about the reality of climate change. This is also something you hear in politics. Many politicians will say things like the science is still questionable. And this is also something you sometimes see in the news. So, for example, this is a debate that happened on CNN in 2012 between these two people. You probably recognize the person on the left here. That's Bill Nye. But the person on the right is someone named Mark Morano. And the key thing that's to emphasize here is that neither of these people are climate scientists. Bill Nye is a science popularizer, and Mark Morano is someone who works in politics. And so the question is, why would a news source want to interview two non-climate scientists? Well, if they did interview climate scientists, it probably would make for a very interesting conversation because they would agree with each other. So instead, they get two people on here to debate it. And this is sometimes called false equivalence. And that is if you have two people on there, one saying yes and one saying no, that it implies that the argument is evenly split between the two. And so it suggests that there's still room for debate. It also suggests as something that could be debated. So, for example, if they were, instead of debating climate change, it was switched to a debate about, is the Earth flat? Well, that would be ridiculous. We would never agree to have such a debate. Well, maybe I shouldn't say we would never, but it's the thing is whether it's the flat Earth or it's climate science. It's a science that's well established and is not up for debate. You can have opinions on what to do about climate change, but whether or not it's actually happening is not something one can have an opinion on. So, unfortunately, when we talk with the public about climate change, they're hearing about it not just from science and science educators. They're also hearing it from other sources. They're hearing it through social media, through politicians, through the news. And so there's a lot of confusion amongst the public about what's going on with climate change and what they should think about it. So what I'd like to do now is pivot to talking a little bit about what are things that we can do as scientists and science educators to help people understand the problem. Well, one of the things that I'd like to do is to ask people questions. I'd like to hear what it is that they think about climate change. And one of the things I do every semester is I ask my students to ask me questions about climate change. And so I'd like to share with you some of the questions my students asked me this last semester. So the first question I have here is simply, how much does a few degrees really matter? And so this is a question basically asking, well, what's the big deal? Why should I even care about this? The second one here is, will solar panels be able to undo the effects, or is it just going to make things worse? And so this person here is raising questions about whether or not the solutions are as bad or maybe even worse as the problem. Here's a third one. This is a longer one where someone questions whether or not scientists are being honest with us. Maybe there's an agenda for us to try to attract funding because as we all know, scientists make lots of money from talking about this sort of stuff. And they also bring up the issue of China. And so this is sometimes called whataboutism, which is when you point the finger at someone else saying, well, what about them? Why aren't they doing something about it? And then finally here, this is one I get very often from my students, where the student asks, this seems like such an insurmountable issue. Is it even possible to address the problem before it's too late? And this question basically is asking whether or not we can solve the problem. And it's asking it as a simple yes or no question. And so that's one of the things I like to emphasize. Climate change is not something we either fix or don't fix. It's literally a matter of degree. So it's not like an asteroid that's either going to hit the Earth or not hit the Earth. It's a question of how bad are things going to get before we fix the problem. So I like to use the analogy of, let's say you have a broken pipe in your basement and it's flooding. The question is, how much flooding are you going to allow happen before you fix the problem? And that's really the question that we have with climate change. So talking with climate change as a scientist, when I first started teaching and talking about it, I felt like if I, as a scientist, my job is just to teach the science, that if I just explain to people what the problem is, then they'll naturally understand what the solutions are. But what I found is that the number one question I get asked is simply, well, what can we do about it? And so one of the things that's very important for us to do is to be able to tell people about what kinds of solutions are available. And that's not to say we should advocate for just one solution, but talk about all the different things that are possible and to be as honest as we can about the pros and cons of each of those. So as I mentioned before, 90% of climate change is from the use of fossil fuels, from their extraction and the burning of them. And that includes petroleum, natural gas, and also coal. So if we can transition how we use our energy, then we have fixed 90% of the problem. Now, of course, doing that is easier said than done for a variety of reasons, but this is what we need to do. The good news is that there are now other energy sources that are now as cheap or cheaper than fossil fuel. So in particular, utility scale solar and utility scale wind power are now able to produce electricity at cheaper costs than using traditional energy sources like coal, natural gas, and nuclear power. And so the good news is that because these energy sources are cheaper, there is a very strong incentive in the free market to adopt them. And so when we used to talk about climate change, we would emphasize that, these other, these other energy sources are more expensive, so we need to switch, even though they're more expensive. To now, it's like these other energy sources are cheaper, so it's something we want to do anyway. So I like to emphasize that for the free market, if able to act as it should, can help us fix the problem. I also like to emphasize that throughout the history of our country, we have constantly been transitioning from one energy source to another. This plot shows that starting for the first 100 years of our country, our primary source of energy was just simply burning trees. We would cut them down, and that would be how we got our energy. Then in the 19th century, we transitioned to fossil fuels like coal, petroleum. And then in the last 50 years or so, we've been dominated by petroleum and natural gas. But if you look in the upper right corner, you'll see that little yellow wedge there. Those are renewable energies, and that is starting to grow very rapidly. So one of the things I emphasize to people is that throughout the history of our country, we have always been transitioning from one energy source to another, and each new energy source was cheaper and cleaner than the previous one. And so it just makes natural sense that we would move on to the next best thing. Okay, finally, what I'd like to talk about is that when we talk about climate change, we have to acknowledge the 800-pound gorilla in the room, and that is that it's not enough for us to just simply talk about the science. As I mentioned earlier, there are other people who are communicating about climate change, and unfortunately, their messages are often misleading, whether it's intentional or not. As I mentioned before, there are companies which have been found to be giving money to organizations that spread doubt about whether or not climate change is real or whether or not it's a problem or if we should do anything about it. Now, this is not unique. And one of the things I like to emphasize is that what the fossil fuel industry is doing now is not the first time this has happened. Many of us are old enough to remember when cigarettes were a regular thing in our society. And in the 50s and the 60s, when science first found evidence that cigarette smoke caused cancer, there was a big pushback from the tobacco industry. And these are some of the advertisements that ran back in those days. And you can see that they're using the same arguments that the fossil fuel industry uses now, that they're saying, well, you've got scientists who say that smoking is a problem. We've got scientists and doctors who say it's not, it's just fine. And so it's very much the same strategies we see nowadays. And it's not unique to fossil fuels or to cigarettes. It's something we've seen in many other industries as well. Whenever science finds that a certain product might be dangerous, then there's often pushback from that industry, whether it be asbestos or sugar or concussions in professional sports. There's often a pushback because it could threaten that industry. Something that we see a lot online, especially in social media, is what's called disinformation. Disinformation is the deliberate spread of things that are factually incorrect with the intent to confuse. And so this is an example of a meme or a graphic that's being spread on social media a few years ago. And what it shows is two covers of Time magazine, one from 1977 and one from 2006. And you can see the cover in 1977 has the headline, How to Survive the Coming Ice Age, whereas the one from 2006 talks about global warming. And so the point of this graphic is to argue that scientists have changed their tune. That back in the 70s, they were claiming that the Earth was getting colder, that we were going into an ice age, and that now they're saying that things are getting hotter. So why should we trust them? Why, if they said first it's getting colder and now saying it's hotter, why should we believe them? Well, first off, I'll say 1977 was a heck of a year. There was a lot of great music that came out that year. But this isn't actually true. This cover is not from 1977. What it is it's a forgery of this cover, which came out in April of 2007. And the real cover is shown here on the right. And I want you to notice that it's been modified. It's been photoshopped. The The headline was changed from the Global Warming Survival Guide to How to Survive the Coming Ice Age. And you'll see that they replaced the things on top as well. They replaced the Sopranos with MASH. They replaced the Iraq War with the Cold War, and so on. And so this is a clear attempt to mislead. Someone forged this with the point of trying to sow doubt about what scientists were actually saying. There's lots of other examples that are out there. And in fact, a lot of the misinformation and disinformation that's coming out nowadays is not attacking climate science, they're attacking climate solutions. So many of the much of the misinformation coming out nowadays is designed to portray wind and solar power and electric cars and other solutions as being either too expensive or actually making the problems worse. And so both of these graphics here are examples of that, where they're either misrepresenting the information or saying things that are just plain wrong. So all of this is known as what's called climate denialism. Denialism is just basically ways of pretending either that the problem isn't real or it's something we don't have to worry about. And so all of these are examples of that. And so the simplest form of denialism is just to say that climate change isn't happening. But we're now at a point where most people have experienced a climate changed event, whether it be a heat wave or a tornado or a hurricane. And so many people are now aware that climate change is affecting the world, in particular where they live. And so now a lot of the climate denialism is focused on attacking solutions. And there's a couple particularly here that I want to point out. One is known as greenwashing, which is pretending that when companies pretend that they're doing things that are good for the environment when they really aren't. And another is what's called climate doomism, which is this bottom one here that says there's nothing we can do about it. And I'll just point out that if you look at these arguments, they're all over the map, right? One of them is saying it doesn't exist at all. And another says it's so bad, we can't do anything about it. And the common thread to all of these is just simply to say that we shouldn't change our behavior. Either it's not a problem or it's such a big problem, we shouldn't even try to fix it. And so one of the things they'll say is that if you ever hear something that argues that we should just continue to do things as we have before, to be very skeptical of it. So one of the things I like to emphasize when talking with people about climate change is there's so much misinformation and disinformation out there. People are genuinely confused. And especially for those of us who work in the field of science and science education and communication, it can just be exasperating. Like, why are people thinking this? Why do they feel this way? And so one of the most important things we can do when talking with people is kind of obvious, and that is just be nice. Be as kind to them as you can to help understand where they are and to have a good conversation with them. So one of the things I think is really important in all the communication we do about climate change is we want people to leave that communication feeling like they were heard and they were respected, and that they're now more interested in learning about it. So if this is someone who's coming to a museum or a planetarium or a science talk, and they have questions about it, if you can help them to feel like, hey, that was really interesting, I want to learn more about it, or wow, I didn't know that, or thanks for answering my questions, I appreciate it, then that's great. We want people to leave feeling like that they're going to be more engaged in the problem. And in particular, I think it's very important, especially for young people, to feel like we've created hope for them. So many of my students are telling me things like that they don't want to have kids because they think the world is going to be so bad in the future. Why even have a life? And so that's part of the effect of this climate doomism that they're being exposed to. A recent study found that 75% of young people say their future is frightening. And it's very hard to live your life if you feel like you don't have a future ahead of you that you're looking forward to. And so we need to help people see that there is a future for us, and it's one that we can actually be pretty excited about. So one of the things I like to do is share examples of success stories. So many of you may remember back in the 70s and 80s, there was a lot of talk about the hole in the ozone layer. And this hole was created by the use of a gas called chlorofluorocarbons, or CFCs. And within the 10 years from when it was discovered, international treaties were passed, the Montreal Protocol, which banned the use of these chlorofluorocarbons, and the hole in the ozone layer is now healing itself. It's actually undoing the damage. And there's plenty of other examples as well, whether it be DDT or various pesticides. We have discovered that there is a problem through the process of science, and we've taken action to fix it. I also really like to share local success stories. So, for example, here in Alaska, the largest island in Alaska and the second largest island in the United States is Kodiak Island. It's a major fishing community, and they have switched over to 100% renewable energy. And as a result, they have made their electricity cheaper. And not only that, they have grown the local economy. A lot of the fish that were being shipped out of state to be processed elsewhere are now being processed on Kodiak Island. So it's a wonderful example of a community recognizing how they can play a role in addressing the problem of climate change and also growing their economy and getting electricity for cheaper. And as someone who lives in Anchorage, it just drives me nuts that they have cheaper electricity than we do. That just doesn't seem right. I also like to share with people many different examples of solutions. And one of my favorite resources for this is a project called Project Drawdown. You can go to their website called drawdown.org and learn about all the different types of solutions that are out there. And most of these are solutions that are just really cool stuff we'd want to do anyways. And I every semester I got my students a challenge to look at this website and find a solution that interests them, whether it be electric cars or regenerative farming or things like that. They always find cool and interesting things to learn more about. Another resource I use in the classroom is called the En-ROADS Climate Simulator. And what this is it's an economic simulator where you can make changes, like changing how we produce energy, energy efficiency, carbon renewal. And I give my students the challenge to use the simulator to create a world where we have addressed with climate change. And they find out it's actually very reasonable to do, that you can change settings on here so that we can keep the temperature change from getting above 1.5 degrees Celsius, which will minimize the impacts of climate change. And so it's a great way of showing people that by employing all these different solutions that are available to us, we can actually address the problem. And one of the things I just like to emphasize is this is not the first time our country has faced an existential crisis. I like to go back to pointing to the history of the space race. When the Soviet Union launched Sputnik, it was a wake-up call to our country that we were behind them technologically in many ways, and we needed to catch up. And so I like to show this picture from the attempt at a first launch of a US rocket in December of 1957, which blew up on the rocket pad. And then 12 years later, we were launching the most powerful rockets ever built to humankind and landing people on the moon. And so it just shows that within 12 years, we can accomplish amazing things. Now, when we set the goal of going to the moon, there were all these major technological hurdles that still needed to be figured out. We didn't have integrated circuits. We had never built rockets of that size. Of course, we didn't have Tang, which we all know is essential for any space travel. And so there were all these major technological hurdles that we had to figure out to make this possible. Now, in contrast, when it comes to climate change, we pretty much have all the solutions ready to go. There are still small things that need to be figured out. But when it comes to the majority of dealing with the climate problem, we have the solutions we need right now. So it's not a matter of technological solutions. It's a matter of sociological and political solutions, making it possible for us to do it. We have everything we need. We just need to go and do it. So since we're back to talking in astronomy and the moon, I'll wrap up with this wonderful quote from Bill Anders, who passed away recently. And he has my favorite quote of all. And he says, "We came all this way to explore the moon. The most important thing that we discovered was the Earth." And I think as astronomers and astronomy communicators, we can use our perspective to share with people what we know about the Earth and about the Earth's climate history and what life is like beyond the Earth and why the Earth is such a special place that needs to be protected. Now, as mentioned at the start of my talk, I am the co-founder and one of the organizers for a group called Astronomers for Planet Earth. It is an organization of astronomers, astronomy educators, amateur astronomers, astronomy enthusiasts, anyone who's interested in working to use astronomy as a way to communicate about the climate crisis. We welcome to our organization. So here's the website. You can come and join us. It's absolutely free. And as also mentioned, we just recently finished a book called Climate Change for Astronomers, which talks about how through the perspective of astronomy, we can talk about the climate crisis. And so here's a link to the book, and so you can check it out there. It is an electronic book available there. So I am more than happy to make my slides available to anyone who wants them. I'll post them and send the link to Bill. That is my presentation. If anyone has any questions or things they'd like to talk about, I'd be more than happy to take your questions. Oh, it looks like you're muted.
First of all, thank you very much. Great presentation.
Oh,
Yeah.
thank you.
Yeah. Thank you very much. A little bit of hope is helpful.
It is a little bit, considering there's a lot of variables going on here. I mean, between the solar system and our stuff doing what we're doing down here, it's like getting your hands around the problem is monumental. It's almost incomprehensible. I watch the ocean every day in Gloucester. I've seen the ocean at a high tide without any storm taking over areas that never were impeded on before. And one of my friends at work, one of the physicists, he pointed out that a little bit of a temperature rise in the water tends to expand. And when the whole oceans are expanding, it doesn't take much for it to affect the shoreline and how it changes every rock a little higher, a little higher. And just going over the bridge out of Gloucester, I watched the marsh behind Freddy's Lobster Land and the bay, and you can see it looked like an inland ocean sometimes. And that's just a normal high tide now, where before it was never quite that severe. Years ago, I had a subscription to Scientific American, and I asked them in a letter, does the amount of airplanes, 10,000 flights every day, change the temperature when you got an engine sucking in cold air and spewing 600-degree exhaust at 30 to 40,000 feet? 10,000 of those can make a difference, I thought. And if they don't, how about the 2 billion cars where every radiator that's exhausting hot air is contributing to warming things? Do you have any idea what those, I mean, it's not a volcano, it's not Krakatoa, it's not a huge, like Yellowstone almost did something a few days ago that looked like it might be getting wound up to go. But, do you ever think about automobiles and the heat that they contribute to the city island heating, things like that?
Yeah, those are all good questions. So those are all different factors that are considered. The energy that actually is released from burning fuels, whether it's in a jet engine or a car engine, is not nearly as important as the gases that are produced from it, because those gases then can trap heat on the surface. And so the primary reason why cities are hotter is because they just have more black surfaces. They have roads that are darker, that absorb sunlight, and then that warms up the local environment. Airplanes are really interesting in that the gases that they produce at high altitude, in particular the contrails they produce, that actually at high altitude, that helps I shouldn't say help because it's not a good thing, but it
It blocks
it slows down the radiation of heat from the Earth. And so that actually warms it up as well.
Oh.
So when it comes to aviation, about almost half of the problem is not just the carbon dioxide produced by the combustion of jet fuel, it's also the contrails they produce.
I know they had a big difference the day after 9/11 when there weren't any airplanes flying. And they said,
Mm-hmm.
"Hey, the skies are clear," and it was cooling things off.
Yeah, so that's a good example of that.
Again, thank you.
We have a
Sure.
local thing here. This occurred to me as you showed the slide of the wind turbine blades being buried. An amazing, a frightening number of people here are convinced that wind turbines deployed offshore are killing whales.
Mm-hmm.
I think it's a phenomenon of a kernel of truth being expanded way beyond its domain of truth. There appear to be some concerns about the effect of sonar and then construction of the platforms undersea, interfering with the navigation capabilities of sea mammals, whales and dolphins and so on. But there are people who claim that the rotation of the turbines, once the facilities are up and producing electricity, are at fault, and it's really amazing. And I've heard, I don't know if this is true or a counter rumor, that a lot of this disinformation is being promoted or, if not peddled, by the fossil fuel industry.
You bring up a really good point, and that is that often these misconceptions are based upon a kernel of truth.
Yeah.
And it's important, I think, to acknowledge that every solution is not perfect, but every solution does have problems. And really the question is how can we adopt all these different solutions while minimizing the problems? Now, obviously, if we were not to set up a wind turbine in the ocean, there would be no impact on that environment at all. There is invariably some impact from putting in the structure needed to put in the wind turbine. And yes, wind turbines can have effects like affecting bird populations and things like that. But what's important is to look at it from the bigger perspective. And that is, if we don't have the wind turbines, then we would be using an equivalent amount of fossil fuels. And what are the impacts of that? And we know that the air pollution caused from fossil fuels are a far greater cause of mortality for bird and sea life than wind turbines are. And so I share those concerns, and we should always, of course, do things that can be done to minimize the impact of these solutions. So, for example, with wind turbines, they're looking at things like if you paint one blade black, it makes it easier for birds to see.
Right.
And so that would minimize. But even if we go with what we have now, the impact on wildlife is far lower for wind and solar than it is for fossil fuels. And so you have to look at that big picture.
Yeah.
To consider
Preaching
that.
to the choir, but it astounds me just to see a real live palpable example of this kind of misinformation running amok in the local social media.
Yeah, well, and it sounds scary. And one of the things that I think is important, one of the challenges is we know what we have now, and the future is always unclear. And so one of the things that I learned about recently that I thought was really interesting is about 100 years ago, there was a survey where they asked people, would you be willing to give up your ice boxes for this new device called the refrigerator? It's a lot easier to use. It's more convenient. You don't have ice delivered to your home and so on. And a lot of people said, no, we're fine. Ice boxes do what we need. It's no problem. We're accustomed to using them. Let's just keep doing that. Now, obviously, that in hindsight, a silly response. We know that refrigerators are just much better. But I think that's kind of where we're at. People are used to a certain thing. And I'll say this, I got an electric car a year ago, and I didn't realize how much I would like it when I got it. Like, yeah, I got it because, I'm concerned about the environment. It seems to make sense. And I'm like, wow, this is so nice. I don't have to go to gas stations. It's quiet. It's smooth. There's so much more about it that I like. And when you have that experience and you realize, wow, it doesn't have to be loud. I don't have to worry about killing myself if I turn it on in the garage. Here in Alaska, the fact that I can use it to warm up the car before I go places in the wintertime, that's incredible. I mean, it's so nice. And once people have those good experiences, then they can better understand it. But new things are always scary from the perspective we don't understand them. Oh, well, wind or solar is going to be worse for X or Y reason. And we just have to do the best we can to inform people about what the options are and how nice they can be. And so pointing to success stories, like Kodiak Island here in Alaska, hey, they've got cheaper electricity than we do. Well, who doesn't want cheaper electricity? I think that's something that, no matter your persuasion or political stripe, we're all pro money. And so, when I put solar panels on my house, my neighbor was like, hey, what's going on there? How do you, and I was like, well, they're great. I like them, blah, blah, blah. Well, now he has them. And so these are examples of how when people can see a solution working, then they're going to be interested in it, especially if they see it working in the community or with respected friends or family or community members.
I think there's this balance between that effect and you've got to overcome sometimes what happens with setbacks. So in the early days of electric refrigeration, you had horror stories about with the wind turbines. It's if it's not the whales, then it's installations that are past the end of their useful life, shedding a blade or something like that, which actually happened here in Gloucester. There were 3 wind turbines in East Gloucester, and now you can see 2 of them if you drive to the end of 128 here. The third one was actually the oldest of the 3, was put in by the Varian Semiconductor Company, which has a facility here. And the company that produced that particular brand of wind turbine went out of business. They had all sorts of trouble with maintaining it, and eventually a blade did fall off. Nobody was hurt. It landed at the base of the installation when nobody was on the work site. Until they were able to dispose of the rest of it, the remaining 2 blades came off like this, and they looked like the mustache of a defeated cartoon villain, and that was gracing the skyline of Gloucester for a few months. But you have and the same is true with nuclear power, right? Fission power, right? There's 3 Mile Island, Fukushima, Chernobyl. Valid questions about managing waste with very long half-lives. I'd be interested to hear a little bit and this is far afield from astronomy, but I'd be interested to hear a little bit more about the history and politics behind light water versus molten salt reactors, for example. We're now turning to molten salt reactors. Bill Gates is funding the construction of them. They had prototypes running at Oak Ridge back in the 1950s, and policy decisions were made that sort of cut the money off from that avenue of research. And they may be much safer to operate in terms of avoiding situations like 3 Mile Island and so on, and produce nuclear waste that is easier to manage. And to get people to listen to that and to buy into it is sometimes a difficult stretch.
Yeah, those are good questions and good points. I think when it comes to nuclear, I was much more of an advocate, I'd say 5 or 10 years ago. My primary concern with nuclear now is just cost effectiveness. Mm-hmm. Wind and solar have dropped so rapidly in price, and nuclear just has not been able to keep up. And it's not clear that it can. So I think my opinion, and this is opinion of many, is that whatever nuclear reactors are up and running now, we should try to keep them running as long as we can. I think it was a mistake for Germany and other countries to shut down their nuclear reactors, because then they switched to coal, and that was worse.
Yeah.
But it's very hard in this economic climate with wind and solar being so cheap now for nuclear. There may be special cases where it'd be appropriate, remote places like the interior of Alaska, possibly, but wind and solar is just, the price continues to drop. Battery power continues to, cost continues to drop. I think we're going to find that the biggest solution are on those two categories. But again, I want to emphasize that all of these solutions can and should play a role at the right time. And nuclear may come around, and the price may get into a sweet spot. But in the meantime, since the clock literally is ticking with climate change, we need to do, what we can now. And right now, wind and solar is just unbeatable.
Given the need for how do you manage the need for energy when there isn't wind or sunshine, and how is large scale storage technology proceeding to enable that? That would be a huge win, and that would accelerate the
I think production is the problem number one. Storage comes after, but the production of wind and solar is still ridiculously small compared to the needs to replace fossil fuels. We are so far from it. In terms of windmills, you were speaking about offshore windmills, and I think it's not a question of birds and things like that, but it's obvious to me that windmills should be onshore, because offshore means huge quantities of concrete and steel to install them. And then, more importantly, you have to maintain them after. And as you know, if you ever was near the sea, the marine environment is extremely corrosive. And these windmills need a lot of maintenance. They need oil, they need replacement of parts and so on. And what's happening is that you have a not in my garden phenomena when people don't want a windmill near their house, right? And then, the solution is to go offshore. I think it's an horrible thing to do. We should really focus on onshore in good sites where there is a lot of wind. As for solar, it's a total aberration that solar is pushed so much in the Northeast here. When you see how many days per year we have clouds, not counting the nights, of course, solar is good in Texas or in Mexico, but it's totally absurd today, I think, in the Northeast. And it exists only because there are tax incentives and premiums, and people can install solar panels north-oriented without paying $1 because the state is paying, which is totally absurd. And it's not how we will solve the problems of this planet. Sorry.
Those are good points.
What about
I'll just
fusion?
say that. Well, I want to emphasize that every solution has strengths and weaknesses. Offshore wind, a couple of the strengths are you can build taller wind turbines because it's very hard to move turbine blades on the ground, but you can build large blades and get them out in the ocean. And they have access to higher and more reliable wind speeds. And so that's a big part of the reason, the attraction of offshore. But the points that you make are also good examples of why onshore can be better. And again, I think it really depends on where, when, and where. So, for example, off the coast of China, they are putting in a tremendous amount of offshore because they have coastal regions that are not very deep, and they're much better suited for it than some coastal areas in the United States where the water gets very deep very quickly. Yeah. And in wind and solar, they have strengths and weaknesses. As they say, the Germans have a word for everything, and they have a word called Dunkelflaut, which means there's no wind and no sun. And that's the thing everyone fears, right? Well, there's ways around it. Of course, battery storage is one way. Another is transmission of electricity by high voltage lines. And you can actually do that with the minimal energy loss. And that's something that's being done, especially in China. And so you can transfer energy from sunny and windy places to places where it's not. And so using a combination of all these solutions is how we're going to get there. It's not going to be that we're just going to do onshore wind or we're just going to do solar. For every location, we need to think about what is the best asset of that location and how can it contribute to fixing the problem for everyone.
Yeah, I hope that we will keep progressing in supraconduction. Because if we could transfer electricity without losses in ambient temperature, that would be a huge progress. As you said, we could put solar panels in the desert and transfer electricity 1,000 miles away without losses. Mm. And there are a lot of progresses being made in that field, but we are not there yet.
Well, we're not.
I'll say even here in Alaska, solar is a good deal, just because even with what limited sun we get, electricity is expensive here. And so my home solar panels will be paid off in 8 years. And to me, that's worth it. Mm-hmm. So it all depends.
Yeah. Well, that's a good sign. And I think we're going to have to terminate our gathering here now. We're at the hour mark. And I want to just thank Travis for coming and joining us and sharing your wisdom, especially about how best to communicate the issues of climate change.
Excellent. Thank you.
All right. So
Have
thank
a great
you all.
night.
Well, thank you all for coming. It was nice to talk with you all.